Today in Algebra 1, Chapter 8, Section 5, we are going to practice writing and graphing exponential functions. But before we do that, let's just take a look at what exponential functions can do. They can do one of two things. They can grow or they can decay. When a number that is greater than 1, such as 3, is raised to an exponent of x, you will have growth. And let's look at why. When you put a number in for x here, so let's make a table of values, and we will go from -1, 0, 1, and 2. When we put those values in for x and figure out what y is, when you put -1 in for x, and that's 3 to the -1, that is 1/3. When you put 0 in for x, 3 to the 0 gives you 1. When you put 1 in for x, 3 to the 1 is 3. And when you put 2 in, you get 3 to the second, which is 9. Do you see that as your exponent x, gets larger, that you're growing, your y values are growing, they are increasing. So you're getting exponential growth, you're growing exponentially. On the flip side of that, if you have y equals 1/3 raised to the...
Are you still here?
One-third raised to the x, and we do the table of values here, and we put values in for x, the same values that we used in the previous problem, -1, 0, 1, and 2. We're going to figure out our y value. So if we put -1 in for x, that's 1/3 to the -1. Okay, remember a negative exponent flips that value, so we're going to get 3. When you put 0 in for x, that's going to be 1/3 to the 0, and that is 1. We'll put 1/3 raised to the 1, and that's 1/3. And 1/3 raised to the second is 1/9. Okay, so as your x value is increasing here, your y value is decreasing exponentially. Why is that? When you take a number greater than 1 and raise it to a power, you get growth. When you take a number between 0 and 1, a fraction or a decimal between 0 and 1, you will get decay. Let's look at these two examples. One who has a number greater than 1, and another one that has a number that we're raising to a power that is between 0 and 1. Okay, we'll make our table of values here, and let's put in 0, 1, and 2. We'll put those values in for x and solve for what our y value would be. So we would have 2 to the -1 gives you 1/2. 2 to the 0 is 1. 2 to the 1 is 2. 2 to the second would be 4. And let's go ahead and put one more x value in, 3. 2 to the third would give you 8. Okay, if we were going to graph that, we could take those ordered pairs and put them on there. -1 gives you 1/2. 0 would give you 1. 1 gives you 2. The ordered pair 2, 4. And 3, 8. Okay, so we can look at this and see that we are growing exponentially. Okay, this will never go below 0 because there is no number that can ever, even a negative number, cannot make 2 completely disappear to 0. So this is growth. Okay, your graph is rising to the right. Your base number here is more than 1. Okay, again, we'll make a table of values. And for x, we're going to put in -1, 0, 1, and 2. When we put -1 in, okay, that is 1/2 to the -1. Again, the negative exponent makes it flip, so we're going to get 2. Exponent of 0 gives us 1. 1/2 to the 1 gives us 1/2. 1/2 to the second gives us 1/4. And 1/2 to the third would give us 1/8. So when we graph these ordered pairs, we will look something like this. -1 will give us 2. 0 gives us 1. 1 would give us 1/2, and then we would become infinitely close to that x-axis without ever actually touching it. Okay, if we were to put in -2, we would get a +4. It'd be up there, and you would see that it would start big, but it would be going down and exponentially decaying because this number here is between 0 and 1. There is an exponential growth formula that we will be using. Y equals A times the quantity of 1 plus r raised to the t. Okay, let's go over what these things are. A is the initial amount invested. R is the interest rate. It will be a percent, and you need to change that into a decimal by moving the decimal 2 places to the left. And T is the time in years. Okay, we're going to use this formula in the next couple of examples. So let's apply this formula to a real problem. Okay, y equals A, which remember is the initial value, times the quantity of 1 plus r, which is your interest rate, raised to the t, which is time in years. So if we have an owner of a car that bought this antique car in 1984 for $11,000, the value of the car says it's increased by 6.9% per year. Okay, how much should he expect to sell the car for in 2004? Let's find our important information. Okay, well, we know that the initial value is 11,000, so that's got to be the A. Okay, the rate is the next thing that we need to know, and it says 6.9%. And then T is the amount of time. Well, he bought it in 1984, and he wants to sell it in 2004, so that's 20 years. So we can plug those values into our formula. Y equals A, which is 11,000, times the quantity of 1 plus the rate, which is 6.9%. Change that into a decimal, 0.069, raised to the T, which is the time in years, and we decided that was 20 years. So you can put that in your calculator, and you will get that Y equals $41,778. So the assignment for 8.5 is, we will start with number 9, and we will go through number 33. We will do the multiples of 3. In addition to that, we will do number 34, and we will do number 38, and we will do number 52. Y'all have a great day.